This is MATHguide.com. My name is Mark Herodimos. Today we're going to take a look at intermediate rational expressions. Just going to take a look at one example and learn how to graph it. So we'll locate its asymptotes and graph it, and we'll see now a problem that's actually going to have several asymptotes. Alright, well, let's take a look at an example. So here is a complex fraction, and I'm going to put here plus 8, and the denominator we're going to have x squared minus 9. Okay, so if we are going to deal with this problem, we first have to factor it, and you'll notice here that there is something in common with those two terms, and I'm going to take it out, and you can see it's a 4, so I'm going to take out a 4, factor it, so it would be 4 times x is 4x, and we're going to have 4 times 2 is 8. Okay, it's been factored, so what I'm going to do is just kind of gently cross it out. Gently. Okay, and let's see, the denominator doesn't have anything in common, right? Those two terms don't have anything in common, so I'm going to use two sets of parentheses. I hope it factors. Okay, well, let's see, this is going to be x plus 3, because there's a difference of two squares. One's going to be positive, and the other one's going to be negative. Alright, then we look to see, does anything going to cancel? So, in other words, is there x plus 2? No, no other x plus 2. Any x plus 3x minus 3 in the numerator? Nope. So it looks like nothing cancels. Alright, so what we do now to find the vertical asymptotes is we set the factors of the denominator equal to 0. So we're going to take the x plus 3, set that equal to 0. Oops, let's get that neater. It's a little glitchy today. Alright, let's see, equals 0. And then we get x minus 3 equals 0. Okay, so let's see. If we were to set those equal to 0, now we solve. So we subtract 3 from both sides, we get a negative 3. Add 3 to both sides, we get a positive 3. Okay, we got 2 there. Alright, next we're going to do is find the horizontal asymptote. And that's based on degree. So let's see, the degree of the numerator is 1, because we have a 1x there. Let's see, the degree of the denominator, well, it's a square, x times x, x squared, that's 2. In the event that the numerator and denominator are different degrees and the degree of the denominator is larger, the horizontal is going to be y equals 0. It's always the case. If they were equal, you would take the ratio of the leading coefficients. So this would be 4 over 1. It would be 4 if their degrees were equal. But they're not, so that's why it's y equals 0. Alright, let's graph this. Well, I'm going to make some more notches here because it looks like I have to get up to 3. Okay, so I'm going to go one beyond it. 2. Okay, so I'm going to try to get 4 notches each way. Okay, there you go. Okay, so let's graph. Well, let's see. X equals, let's start with negative 3. So right over here, I draw an asymptote going through negative 3 on the x-axis. Alright, and then through 3. Alright, and then of course y equals 0. That is the x-axis. Right on the x-axis. Okay, so put little arrows there. So there we go. We got my asymptotes. Now we just have to figure out where the curve is. Now this is where people pick up a graphing calculator. Instead, what I'm going to do is I'm going to create a table of values. Okay, and what I am going to do is basically I want to know what's happening over here in the center. So I'm going to pick like a -1, a 0, a 1. I might even put in a -2. So I get -2, -1, 0, and 1. I think that might be enough to tell what's happening in the middle. So -2, -1, 0, and 1. I'll find the corresponding y values. Okay, and of course I'd like to see what's happening over here too. So that would be -4. That's going to make some values, and I'll plot some points, right? This is what you would do if you want to find a graph, find a picture of the graph. And I'll also try 4 and see what's happening over there as well. Okay, so I'll find corresponding values here. I'm going to do a couple here, and then what I'll do is I'll just fill it in. I'll pause the video and fill them in just to save some time. Alright, well here when x is 0, that's an easy one to do. You plug it in either to the original or the ones that are factors. If I plug it in here, I put 0, 4 times 0, 0, we get 8. 0 squared is 0, 0 minus 9 is -9. So I get 8 over -9, and that's close to -1. Yeah, I know it's not equal to -1, but it's going to be close enough. Okay, it's approximately. I'll put like a little wavy mark there. So it's approximately going to be -1. Okay, like I said, I'm going to plug in some more, and that's the process I'm going to do, except I'm going to do that without wasting time. So I'm going to pause the video and fill the table. Alright, as you can see, I filled the table, and I've got a good idea of what this curve looks like. Alright, I'm going to put this in blue. Alright, so I know I've got 0, -1. It's right over here. A little glitchy today. Alright, let's see, -2 is 0. Over there. Let's see, -1, -2 is somewhere around here. And it's kind of hard to get the exact point, but you're going to get the picture. Let's see, I've got 1, -1.5, somewhere over here. Okay, let's see, at -4, way over here, I know it's negative. So it's going to be somewhere, and it's just kind of over here. I did it, and it's just into the negatives. And over here at 4, I know it's positive, so somewhere it's over here somewhere. I did calculation and didn't get exact numbers, but I got a feeling for what happens. Okay, so if you understand how asymptotes work, the curve will always get closer and closer. It's not supposed to touch. Weird things happen. In this case, actually the curve briefly passes over this horizontal asymptote. Okay, so if you can excuse this, it does go past it, but then it gets closer and closer and closer to that asymptote right there. So then it continues over here, and then that was awful. Let's try that again. Okay, so then it goes through that point down here, and then it goes closer and closer and closer to that asymptote, like that. So, remember the asymptotes are guides. And, yeah, it does briefly cross over the horizontal, but it does get closer and closer and closer to this vertical one. Here it's getting closer and closer and closer to the this other vertical one. And then, briefly over here in the middle, it wants to follow this one, but it has to go up. Why? It's beyond me mathematically why that exactly happens, but if you take a look at the picture in a graphing calculator and plot some points, you'll get these points to start to appear. Okay, and then it's a little bit more traditional in this end. When you graph more points, it actually starts to look like this. It has that familiar looking shape. Okay, and over here it kind of does a familiar shape, follows that asymptote, and then it goes this way, following that asymptote. So it has this weird wraparound effect. Okay, and it has that shape, and that's what this curve looks like. So it is kind of nutty, very different than the basic level. And plotting points and looking at a graphing calculator really help. Okay, so that's what it looks like. That's all there is to it. If you want to go back to MATHguide.com, you can check out our interactive quizzes, check out our other videos, and of course our text lessons. Thanks. Take care.